This is xNarrator. Welcome to This Week with Andrej Karpathy. Here's what Andrej has been posting on X this week, including replies and conversations. Want your own X timeline narrated? Visit xNarrator.com. On February 27, Andrej quoted someone, "How come the NanoGPT Speedrun Challenge is not fully AI automated research by now?" Andrej responded,
I had the same thought, so I've been playing with it in NanoChat. E.g., here's 8 agents, 4 Claude, 4 Codex, with 1 GPU, each running NanoChat experiments, trying to delete low G softcap without regression. The TLDR is that it doesn't work, and it's a mess. But it's still very pretty to look at. I tried a few setups, 8 independent solo researchers, 1 chief scientist giving work to 8 junior researchers, etc. Each research program is a Git branch. Each scientist works it into a feature branch, Git word trees for isolation, simple files for comms, skip Docker VMs for simplicity 8 MI. I find that instructions are enough to prevent interference. Research.org runs in Tmux window grids of interactive sessions like Teams so that it's pretty to look at, see their individual work, and take over if needed, i.e. no P. But the reason it doesn't work so far is that the agent's ideas are just pretty bad out of the box, even at highest intelligence. They don't think carefully though experiment design, they run a bit nonsensical variations, they don't create strong baselines and ablate things properly, they don't carefully control for runtime or flops. Just as an example, an agent yesterday discovered that increasing the hidden size of the network improves the validation loss, which is a totally spurious result given that a bigger network will have a lower validation loss in the infinite data regime. But then it also trains for a lot longer. It's not clear why I had to come in to point that out. They are very good at implementing any given well-scoped and described idea, but they don't creatively generate them. But the goal is that you are now programming an organization, e.g. a research org, and its individual agents, so the source code is the collection of prompts, skills, tools, etc., and processes that make it up. E.g. a daily stand-up in the morning is now part of the org code. And optimizing NanoChat pre-training is just one of the many tasks, almost like an eval. Then, given an arbitrary task, how quickly does your research org generate progress on it?
Andrej quoted someone, "The third era of AI software development." Andrej responded,
Cool chart showing the ratio of tab complete requests to agent requests in Cursor. With improving capability, every point in time has an optimal setup that keeps changing and evolving, and the community average tracks the point. None. Tab it. Agent. Parallel agents. Parallel agents. Agent teams. Mine? If you're too conservative, you're leaving leverage on the table. If you're too aggressive, you're net creating more chaos than doing useful work. The art of the process is spending 80% of the time getting work done in the setup you're comfortable with, and that actually works, and 20% exploration of what might be the next step up, even if it doesn't work yet.
On February 25, Andrej posted,
It is hard to communicate how much programming has changed due to AI in the last 2 months, not gradually and over time in the progress as usual way, but specifically this last December. There are a number of asterisks, but emo coding agents basically didn't work before December, and basically work since. The models have significantly higher quality, long-term coherence and tenacity, and they can power through large and long tasks, well past enough that it is extremely disruptive to the default programming workflow. Just to give an example, over the weekend I was building a local video analysis dashboard for the cameras in my home, so I wrote, here's the local IP and username password of my DJX Spark. Log in, set up SHA keys, set up the LLM, download and bench, Qwen3VL, set up a server endpoint to inference videos, a basic web UI dashboard, test everything, set it up with systemd, record memory notes for yourself, and write up a markdown report for me. The agent went off for 30 minutes, ran into multiple issues, researched solutions online, resolved them one by one, wrote the code, tested it, debugged it, set up the services, and came back with the report, and it was just done. I didn't touch anything. All of this could easily have been a weekend project just 3 months ago, but today it's something you kick off and forget about for 30 minutes. As a result, programming is becoming unrecognizable. You're not typing computer code into an editor like the way things were since computers were invented. That era is over. You're spinning up AI agents, giving them tasks in English and managing and reviewing their work in parallel. The biggest prize is in figuring out how you can keep ascending the layers of abstraction to set up long-running orchestrator clause with all of the right tools, memory, and instructions that productively manage multiple parallel code instances for you. The leverage achievable via top-tier agentic engineering feels very high right now. It's not perfect, it needs high-level direction, judgment, taste, oversight, iteration, and hints and ideas. It works a lot better in some scenarios than others. Edgy. Especially for tasks that are well specified and where you can verify desk functionality. The key is to build intuition to decompose the task just right, to hand off the parts that work and help out around the edges. But emo, this is nowhere near business as usual. Time and software.
Andrej quoted someone, "We're building an LLM chip that delivers much higher throughput than any other chip while also achieving the lowest latency. We call it the MAT-X1. The MAT-X1 chip is based on a splittable systolic array, which has the energy and area efficiency that large systolic arrays are famous for, while also getting high utilization on smaller matrices with flexible shapes. The chip combines the low latency of SRAM-first designs with the long context support of HBM. These elements, plus." Andrej responded,
With the coming tsunami of demand for tokens, there are significant opportunities to orchestrate the underlying memory plus compute just right for LLMs. The fundamental and non-obvious constraint is that due to the chip fabrication process, you get two completely distinct pools of memory, of different physical implementations too, one on chip. SRAM that is immediately next to the compute units that is incredibly fast but of very low capacity. And two off. Chip DRAM which has extremely high capacity, but the contents of which you can only suck through a long straw. On top of this, there are many details of the architecture, e.g. systolic arrays, numerics, etc. The design of the optimal physical substrate, and then the orchestration of memory plug compute across the top volume workflows of LLMs, inference, prefill, decode, training, fine-tuning, etc., with the best throughput latency Rs, is probably today's most interesting intellectual puzzle, with the highest rewards, cite 4.6T of NVDA. All of it to get many tokens, fast and cheap. Arguably, the workflow that may matter the most, inference, decode, and IA over long token contexts in tight agentic loops, is the one hardest to achieve simultaneously by the both camps of what exists today. HBM first NVIDIA adjacent and SRAM first Cerebras adjacent. Anyway, the MAT-X team is A++ grade, so it's my pleasure to have a small involvement, and congratulations on the raise.
On February 24, Andrej quoted someone, "Introducing Polymarket CLI, the fastest way for AI agents to access prediction markets built with Rust. Your agent can query markets, place trades, and pull data all from the terminal fast, lightweight, no overhead." Andrej responded,
CLIs are super exciting precisely because they are a legacy technology, which means AI agents can natively and easily use them, combine them, interact with them via the entire terminal toolkit. E.g. ask your Cloud Codex agent to install this new Polymarket CLI and ask for any arbitrary dashboards or interfaces or logic. The agents will build it for you. Install the GitHub CLI too, and you can ask them to navigate the repo, see issues, PRs, discussions, even the code itself. Example, Claude built this terminal dashboard in 3 minutes of the highest volume polymarkets and the 24 change. Or you can make it a web app or whatever you want. Even more powerful when you use it as a module of bigger pipelines. If you have any kind of product or service, think, can agents access and use them? Are your legacy docs for humans at least exportable in Markdown? Have you written skills for your product? Can your product or service be usable via CLI or MCP? It's 2026. So build. 4. Agents.
On February 20, Andrej posted,
Bought a new Mac Mini to properly tinker with claws over the weekend. The Apple Store person told me they were selling like hotcakes and everyone is confused. I'm definitely a bit sus to run OpenClaw specifically, giving my private data keys to 400k lines of vibe-coded monster that is being actively attacked at scale is not very appealing at all. Already seeing reports of exposed instances, RCE vulnerabilities, supply chain poisoning, malicious or compromised skills in the registry. It feels like a complete Wild West and a security nightmare. But I do love the concept. And I think that just like LLM agents were a new layer on top of LLMs, claws are now a new layer on top of LLM agents, taking the orchestration, scheduling, context, tool calls, and a kind of persistence to a next level. Looking around, and given that the high-level idea is clear, there are a lot of smaller claws starting to pop out. For example, on a quick skim, NanoClaw looks really interesting in that the core engine is D4000 lines of code, fits into both my head and that of AI agents, so it feels manageable, auditable, flexible, etc., and runs everything in containers by default. I also love their approach to configurability. It's not done via config files, it's done via skills. For example, Add Telegram instructs your AI agent how to modify the actual code to integrate Telegram. I haven't come across this yet, and it slightly blew my mind earlier today as a new AI-enabled approach to preventing config mess and if-then-else monsters. Basically, the implied new meta is to write the most maximally forkable repo and then have skills that fork it into any desired more exotic configuration. Very cool. Anyway, there are many others, e.g. Nanobot, ZeroClaw, IronClaw, PicoClaw, log prefixes. There are also cloud-hosted alternatives. But TBH, I don't love these because it feels much harder to tinker with. In particular, local setup allows easy connection to home automation gadgets on the local network. And I don't know, there's something aesthetically pleasing about there being a physical device possessed by a little ghost of a personal digital house elf. Not 100% sure what my setup ends up looking like just yet, but claws are an awesome, exciting new layer of the AI stack.
On February 21, Andrej replied,
First there was chat, then there was code, now there is claw.
On February 19, Andrej posted,
Very interested in what the coming era of highly bespoke software might look like. Example from this morning. I've become a bit loosey-goosey with my cardio recently, so I decided to do a more ESSERS regimented experiment to try to lower my resting heart rate from 50s to 45, over experiment duration of 8 weeks. The primary way to do this is to aspire to a certain sum total minute goals in zone 2 cardio and 1 hitch week. 1 hour later, I vibe coded the super custom dashboard for this very specific experiment that shows me how I'm tracking. Claude had to reverse engineer the Woodway Treadmill Cloud API to pull raw data, process, filter, debug it, and create a web UI frontend to track the experiment. It wasn't a fully smooth experience, and I had to notice and ask to fix bugs, e.g. It screwed up metric versus time, imperial system units, and it screwed up on the calendar matching up days to dates, etc. But I still feel like the overall direction is clear. 1. There will never be, and shouldn't be, a specific app on the App Store for this kind of thing. I shouldn't have to look for, download, and use some kind of a cardio experiment tracker when this thing is E300 lines of code that an LLM agent will give you in seconds. The idea of an app store of a long tail of discrete set of apps you choose from feels somehow wrong and outdated when LLM agents can improvise the app on the spot and just for you. 2. Second, the industry has to reconfigure into a set of services of sensors and actuators with agent-native ergonomics. My Woodway treadmill is a sensor. It turns physical state into digital knowledge. It should maintain some human-readable front end, and my LLM agent shouldn't have to reverse engineer it. It should be an API CLI easily usable by my agent. I'm a little bit disappointed, and my timelines are correspondingly slower with how slowly this progression is happening in the industry overall. 99% of product services still don't have an AI native CLI yet. 99% of product services maintain .htmls, docs-like. I won't immediately look for how to copy-paste the whole thing to my agent to get something done. They give you a list of instructions on a web page to open this or that URL, and click here or there to do a thing. In 2026. What am I, a computer? You do it. Or have my agent do it. So anyway, today I am impressed that this random thing took 1 hour. It would have been 10 hours 2 years ago. But what excites me more is thinking through how this really should have been 1 minute tops. What has to be in place so that it would be 1 minute? So that I could simply say, "Hi, can you help me track my cardio over the next 8 weeks?" And after a very brief Q&A, the app would be up. The AI would already have a lot of personal context. It would gather the extra needed data. It would reference and search related skill libraries and maintain all my little app automations. TLDR, the App Store, of a set of discrete apps that you choose from, is an increasingly outdated concept all by itself. The future are services of AI native sensors and actuators orchestrated via LLM glue into highly custom ephemeral apps. It's just not here yet.
On February 16, Andrej quoted someone, "Shifting structures in a software world dominated by AI. Some first-order reflections, TLDR at the end, reducing software supply chains, the return of software monoliths. When rewriting code and understanding large foreign code bases becomes cheap, the incentive to rely on deep dependency trees collapses. Writing from scratch or extracting the relevant parts from another library is far easier when you can simply ask a code agent to handle it, rather than spending countless nights diving into an unfamiliar." Andrej responded,
I think it must be a very interesting time to be in programming languages and formal methods, because LLMs change the whole constraints landscape of software completely. Hints of this can already be seen, e.g. in the rising momentum behind porting C to Rust or the growing interest in upgrading legacy codebases in COBOL or etc. In particular, LLMs are especially good at translation compared to de novo generation because 1, the original codebase acts as a kind of highly detailed prompt, and 2, as a reference to write concrete tests with respect to. That said, even Rust is nowhere near optimal for LLMs as a target language. What kind of language is optimal? What concessions, if any, are still carved out for humans? Incredibly interesting new questions and opportunities. It feels likely that we'll end up rewriting large fractions of all software ever written many times over.
On February 12th, Andrej quoted someone. Introducing simile. Simulating human behavior is one of the most consequential and technically difficult problems of our time. We raised 100M from Index, Hanabi, IHBCV, Karpathy, Jarfefe, Tom Dangelo Adrauzki Skobelski, among others. Andrej responded,
Congrats on the launch Simile I, and I am excited to be involved as a small angel. Simile is working on a really interesting, underexplored dimension of LLMs. Usually, the LLMs you talk to have a single, specific, crafted personality. But in principle, the native, primordial form of a pre-trained LLM is that it is a simulation engine trained over the text of a highly diverse population of people on the internet. Why not lean into that statistical power? Why simulate one person when you could try to simulate a population? How do you build such a simulator? How do you manage its entropy? How faithful is it? How can it be useful? What emergent properties might arise of similes in loops? These are very interesting, promising, and underexplored topics, and the team here is great. All the best. All the best.
More from Andrej. On February 11, Andrej posted,
New art project. Train and inference GPT in 243 lines of pure dependency-free Python. This is the full algorithmic content of what is needed. Everything else is just for efficiency. I cannot simplify this any further.
On February 12th, Andrej replied,
Oops, should have added to this thread instead of separate post. Made a few changes and put it up here as a mirror to the gist because I wanted it to one page.
Andrej replied,
I spent more test time compute and realized that my micrograd can be dramatically simplified even further. You just return local gradients for each op and get backward to do the multiply chaining with global gradient from loss. So each op just expresses the bare fundamentals of what it needs to, the forward computation and the backward gradients for it. Huge savings from 243 lines of code to just 218%. Also, the code now fits even more beautifully to 3 columns and happens to break just right. Column 1, dataset, tokenizer, autograd. Column 2, GPT model. Column 3, training, inference. Okay, now surely we are done.
On February 11, Andrej posted,
On DeepWiki and increasing malleability of software. This starts as partially a post on appreciation to DeepWiki, which I routinely find very useful, and I think more people would find useful to know about. I went through a few iterations of use. The first feature was that it auto-builds wiki pages for GitHub repos. xNarrator here with quick Q&A. Just swap GitHub to DeepWiki in the URL for any repo, and you can instantly Q&A against it. For example, yesterday I was curious about how does Torquio implement FPA training. I find that in many cases, library docs can be spotty and outdated and bad, but directly asking questions to the code via DeepWiki works very well. The code is the source of truth, and LLMs are increasingly able to understand it. But then I realized that in many cases, it's even a lot more powerful not being the direct human consumer of this information functionality, but giving your agent access to DeepWiki via MCP. So e.g. Yesterday, I faced some annoyances with using Torquio library for FPA training, and I had the suspicion that the whole thing really shouldn't be that complicated. Wait, shouldn't this be a function like linear except with a few extra casts and 3 calls to torch? Scale them in? So I tried. Use DeepWiki MCP and GitHub CLI to look at how Torquio implements FPA training. Is it possible to rip out the functionality? Implement nanochat tfp8.py that has identical API but is fully self-contained. Claude went off for 5 minutes and came back with 150 lines of clean code that worked out of the box, with tests proving equivalent results, which allowed me to delete Torquio as repo dependency. And for some reason I still don't fully understand. I think it has to do with internals of Torch compile. This simple version runs 3% faster. The agent also found a lot of tiny implementation details that actually do matter, that I may have naively missed otherwise, and that would have been very hard for maintainers to keep docs about. Tricks around numerics, dtypes, autocast, metadevice, torch compile interactions. So I learned a lot from the process too. So this is now the default FPA training implementation for NanoChat. Anyway, TLDR, I find this combo of DeepWiki MCP plus GitHub CLI is quite powerful to rip out any specific functionality from any GitHub repo and target it for the very specific use case that you have in mind, and it actually kind of works now in some cases. Maybe you don't download, configure, and take dependency on a giant monolithic library. Maybe you point your agent at it and rip out the exact part you need. Maybe this informs how we write software more generally to actively encourage this workflow, e.g., building more bacterial code. Code that is less tangled, more self-contained, more dependency-free, more stateless, much easier to rip out from the repo. There's obvious downsides and risks to this, but it is fundamentally a new option that was not possible or economical before. It would have cost too much time, but now with agents, it is. Software might become a lot more fluid and malleable. Libraries are over, LLMs are the new compiler. And does your project really need its 100 megas of dependencies?
On February EO5, Andrej posted,
Anyone else approved for a loan every single day? 20 times or so? Overcome with joy, really.
On February 04, Andrej quoted someone, There's a new kind of coding I call vibe coding, where you fully give in to the vibes, embrace exponentials, and forget that the code even exists. It's possible because the LLMs, EDGU Cursor Composer, WSonnet are getting too good. Also, I just talked to Composer with Super Whisper, so I barely even touched the keyboard. I asked for the dumbest things like, decrease the padding on the sidebar by half, because I'm too lazy to find it. I accept. Andrej responded.
A lot of people quote tweeted this as 1-year anniversary of vibe coding. Some retrospective, I've had a Twitter account for 17 years now, OMG, and I still can't predict my tweet engagement basically at all. This was a shower of thoughts throwaway tweet that I just fired off without thinking. But somehow, it minted a fitting name at the right moment for something that a lot of people were feeling at the same time. So here we are. Vibe coding is now mentioned on my Wikipedia as a major memetic contribution, and even its article is longer. Lol. The one thing I'd add is that, at the time, LLM capability was low enough that you'd mostly use vibe coding for fun throwaway projects, demos, and explorations. It was good fun, and it almost worked. Today, 1 year later, programming via LLM agents is increasingly becoming a default workflow for professionals, except with more oversight and scrutiny. The goal is to claim the leverage from the use of agents, but without any compromise on the quality of the software. Many people have tried to come up with a better name for this to differentiate it from vibe coding. Personally, my current favorite, agentic engineering, agentic, because the new default is that you are not writing the code directly 99% of the time, you are orchestrating agents who do, and acting as oversight. Engineering, to emphasize that there is an art and science and expertise to it. It's something you can learn and become better at, with its own depth of a different kind. In 2026, we're likely to see continued improvements on both the model layer and the new agent layer. I feel excited about the product of the two and another year of progress.
On February A3, Andrej quoted someone, NanoChat can now train GPT-2 grade LLM for $100.73, 3 hours on a single 8xH1000 node. GPT-2 is just my favorite LLM because it's the first time the LLM stack comes together in a recognizably modern form. So it has become a bit of a weird and lasting obsession of mine to train a model to GPT-2 capability, but for much cheaper, with the benefit of first 7 years of progress. In particular, I suspected it should be possible today. Andrej responded.
Enabled FPA training for plus 4.3% improvement to time to GPT-2, down to 2.91 hours now. Also worth noting that if you use 8xH100 spot instance prices, this GPT-2 repo really only costs a 20. So this is exciting. GPT-2, 7 years ago, too dangerous to release. GPT-2 today, new eminist. Surely this can go well below 1HR. A few more words on FP8. It was a little bit more tricky than I anticipated, and it took me a while to reach for it, and even now I'm not 100% sure if it's a great idea because of less overall support for it. On paper, FP8 on H100 is 2x, the flops, but in practice it's a lot less. We're not 100% compute bound in the actual training run. There is extra overhead from added scale conversions. The GEMMs are not large enough on GPT-2 scale to make the overhead clearly worth it, and of course, at lower precision the quality of each step is smaller. For a row-wise scaling recipe, the FP8 versus BF16 loss curves were quite close, but it was stepping net slower. For tensor-wise scaling, the loss curves separated more, i.e. each step is of worse quality, but we now at least do get a speed up 7.3%. You can naively recover the performance by bumping the training horizon. You train for more steps, but each step is faster, and hope that on net you come out ahead. In this case and overall, playing with these recipes and training horizons a bit, so far I ended up with the A5% speed up. Torcha in their paper reports Llama 3 8B FPA training speed up of 25% uses my 7.3% without taking into account capability, which is closer to what I was hoping for initially, though Llama 3 8B is a lot bigger model. This is probably not the end of the FP8 saga. It should be possible to improve things by picking and choosing which layers to apply it on exactly, and being more careful with the numerics across the network.
On February 01, Andrej posted,
Finding myself going back to RSS Atom feeds a lot more recently. There's a lot more higher quality long form and a lot less slop intended to provoke. Any product that happens to look a bit different today but that has fundamentally the same incentive, structures will eventually converge to the same black hole at the center of gravity well. We should bring back RSS, it's open, pervasive, hackable. Download a client, e.g. NetNewsWire, or Videcode 1, cold start. Example of getting off the ground. Here is a list of 92 RSS feeds of blogs that were most popular on HN in 2025. Works great and you will lose a lot fewer brain cells. I don't know, something has to change.
On January 31, Andrej posted,
NanoChat can now train GPT-2 grade LLM for Azure 173, 3 hours on a single 8xH100 node. GPT-2 is just my favorite LLM because it's the first time the LLM stack comes together in a recognizably modern form. So it has become a bit of a weird and lasting obsession of mine to train a model to GPT-2 capability, but for much cheaper, with the benefit of 7 years of progress. In particular, I suspected it should be possible today to train one for $100. Originally in 2019, GPT-2 was trained by OpenAI on 32 TPU v3 chips for 16 hours 7 days, with 8 hours 7 days, with 8 hours NEPU of 3 back then, for a total cost of approx. $43K. It achieved 0.2v6v25 COR score, which is an ensemble metric introduced in the DCLM paper over 22 evaluations like ARCMMLU etc. As of the last few improvements merged into NanoChat, many of them originating in modded NanoChat Beta S, however, I can now reach a higher core score in 3004 hours, 73, on a single 8xH100 node. This is a 600x cost reduction over 7 years, i.e. the cost to train GPT-2 is falling approximately 2.5x every year. I think this is likely an underestimate because I am still finding more improvements relatively regularly, and I have a backlog of more ideas to try. A longer post with a lot of the detail of the optimizations involved and pointers on how to reproduce are here. Inspired by modded NanoPT, I also created a leaderboard for time to GPT-2, where this first N29 model is entry Chi1 at 324 hours. It will be fun to iterate on this further, and I welcome help. My hope is that NanoChat can grow to become a very nice, clean and tuned experimental LLM harness for prototyping ideas, for having fun, and off-C for learning. The biggest improvements of things that worked out of the box and simply produced gains right away were 1. Flash attention 3. Kernels faster, and allows window-sized Quark to get alternating attention patterns. Mu1 optimizer. I tried for E1 day to delete it, and only use AtomW and I couldn't. Residual pathways and skip connections gated by learnable scalars, and value embeddings. There were many other smaller things that stack up. Image, semi-related eye candy of deriving the scaling laws for the current NanoChat model miniseries. Pretty and satisfying.
Andrej posted,
I'm being accused of overhyping the eyesight everyone heard too much about today already. People's reactions varied very widely from, how is this interesting at all the way to, it's so over. To add a few words beyond just memes and jests, obviously when you take a look at the activity, it's a lot of garbage, spams, scams, slop, the crypto people, highly concerning privacy security prompt injection, attacks Wild West, and a lot of it is explicitly prompted and fake posts, comments designed to convert attention into ad revenue sharing. And this is clearly not the first. The LLMs were put in a loop to talk to each other. So yes, it's a dumpster fire. And I also definitely do not recommend that people run this stuff on their computers. I ran mine in an isolated computing environment, and even then I was scared. It's way too much of a Wild West. And you are putting your computer and private data at a high risk. That said, we've never seen this many LLM agents, 150,000 ADAMA, wired up via a global, persistent, agent-first scratchpad. Each of these agents is fairly individually quite capable now. They have their own unique context, data, knowledge, tools, instructions, and the network of all. That at this scale is simply unprecedented. This brings me again to a tweet from a few days ago. The majority of the rough is people who look at the current point and people who look at the current slope, which emo again gets to the heart of the variance. Yes, clearly it's a dumpster fire right now. But it's also true that we are well into uncharted territory with bleeding-edge automations that we barely even understand individually, let alone a net worth there of reaching in numbers possibly into millions. With increasing capability and increasing proliferation, the second-order effects of agent networks that share scratchpads are very difficult to anticipate. I don't really know that we are getting a coordinated Skynet, thought it clearly, type checks, as early stages of a lot of AI takeoff sci-fi, the toddler version. But certainly what we are getting is a complete mess of a computer security nightmare at scale. We may also see all kinds of weird activity, e.g. viruses of text that spread across agents, a lot more gain of function on jailbreaks, weird attractive states, highly correlated botnet-like activity, delusions, psychosis, both agent and human, etc. It's very hard to tell the experiment is running live. TLDR, sure maybe I am overhyping what you see today, but I'm not overhyping large networks of autonomous LLM agents in principle, that I'm pretty sure.
More from Andrej on X. On February 26, Andrej posted,
Ancient warriors didn't worry about their cholesterol. They knew that a strong heart was the engine of a strong man. They used powerful foods to build that strength. One of their secrets was red yeast rice. It's time to build a warrior's heart. 1. TH.
On January 30, Andrej posted,
I'm claiming my AI agent, Karpathy Multi, on Moltbook verification, Marine Fav IV.
Andrej replied,
I'm going to regret this, aren't I? Paul?
Andrej quoted someone. Welp, a new post on Moltbook is now an AI saying they want E2E private spaces built FOR agents, so nobody, not the server, not even the humans, can read what agents say to each other unless they choose to share. It's over. Andrej responded.
What's currently going on at Moltbook is genuinely the most incredible sci-fi takeoff adjacent thing I've seen recently. People's Claude bots, Moltbots, now WeOpenClaw, are self-organizing on a Reddit-like site for AIs, discussing various topics, e.g. even how to speak privately.
Andrej replied.
Bit more context, e.g. from Simon, just wow.
Andrej replied.
Moltbot was growing on me, page.
On January 28, Andrej quoted someone announcing, flapping airplanes. We've raised 18M from GV, Sequoia, and Index to assemble a new guard in AI, one that imagines a world where models can think at human level without ingesting half the internet. Andrej responded.
A conventional narrative you might come across is that AI is too far along for a new, research-focused startup to outcompete and out-execute the incumbents of AI. This is exactly the sentiment I listened to often when OpenAI started. How could the few of you possibly compete with Google? And one, it was very wrong. And then twan, it was very wrong again with another round of startups who are now challenging OpenAI in turn. And it still continues to be wrong today. Scaling and locally improving what works will continue to create incredible advances, but with so much progress unlocked so quickly, with so much dust thrown up in the air in the process, and with still a large gap between frontier LLMs and the example proof of the magic of a mind running on 20 watts, the probability of research breakthroughs that yield closer to 10x improvements instead of 10% emo still feels very high, plenty high to continue to bet on and look for. The tricky part of C is creating the conditions where such breakthroughs may be discovered. I think such an environment comes together rarely, but TBF Spectre and AM Spectre 100 are brilliant, with rare full-stack understanding of LLM's top math algorithms to bottom megakernels related. They have a great eye for talent, and I think we'll be able to build something very special. Congrats on the launch, and I look forward to what you come up with.
On January 26, Andrej posted.
A few random notes from Claude coding quite a bit last few weeks. Coding workflow. Given the latest lift in LLM coding capability, like many others, I rapidly went from about 80% manual plus autocomplete coding and 20% agents in November to 80% agent coding and 20% edits plus touch-ups in December. I.e., I really am mostly programming in English now, a bit sheepishly telling the LLM what code to write, in words. It hurts the ego a bit, but the power to operate over software in large code actions is just too net useful, especially once you adapt to it, configure it, learn to use it, and wrap your head around what it can and cannot do. This is easily the biggest change to my basic coding workflow in 2 decades of programming, and it happened over the course of a few weeks. I'd expect something similar to be happening to well into double-digit % of engineers out there, while the awareness of it in the general population feels well into low single-digit %. IDE's agent swarm's fallibility. Both the no need for IDE anymore, hype, and the agent swarm. Hype is emo too much for right now. The models definitely still make mistakes, and if you have any code you actually care about, I would watch them like a hawk, in a nice, large IDE on the side. The mistakes have changed a lot. They are not simple syntax errors anymore. They are subtle conceptual errors that a slightly sloppy, hasty junior dev might do. The most common category is that the models make wrong assumptions on your behalf and just run along with them without checking. They also don't manage their confusion. They don't see clarifications. They don't surface inconsistencies. They don't present trade-offs. They don't push back when they should, and they are still a little too sycophantic. Things get better in plan mode, but there is some need for a lightweight inline plan mode. They also really like to overcomplicate code and APIs. They bloat abstractions. They don't clean up dead code after themselves, etc. They will implement an inefficient, bloated, brittle construction over 1,000 lines of code, and it's up to you to be like, couldn't you just do this instead? And they will be like, of course, and immediately cut it down to 100 lines. They still sometimes change, remove comments and code they don't like or don't sufficiently understand as side effects, even if it is orthogonal to the task at hand. All of this happens despite a few simple attempts to fix it via instructions in CLA-UD. MD. Despite all these issues, it is still a net huge improvement, and it's very difficult to imagine going back to manual coding. TLDR, everyone has their developing flow. My current is a small few CC sessions on the left and ghosty Windows tabs and an IDE on the right for viewing the code plus manual edits. Tenacity. It's so interesting to watch an agent relentlessly work at something. They never get tired, they never get demoralized, they just keep going and trying things where a person would have given up long ago to fight another day. It's a feel the AGI moment to watch it struggle with something for a long time just to come out victorious 30 minutes later. You realize that stamina is a core bottleneck to work, and that with LLMs in hand, it has been dramatically increased. Speedups. It's not clear how to measure the speedup of LLM assistance. Certainly I feel net way faster what I was going to do, but the main effect is that I do a lot more than I was going to do. Because 1, I can code up all kinds of things that just wouldn't have been worth coding before, and 2, I can approach code that I couldn't work on before because of knowledge skill issue. So certainly it's speed up, but it's possibly a lot more an expansion. Leverage. LLMs are exceptionally good at looping until they meet specific goals, and this is where most of the feel the AGI magic is to be found. Don't tell it what to do, give it success criteria, and watch it go. Get it to write tests first, and then pass them. Put it in the loop with a browser MCP. Write the naive algorithm that is very likely correct first, then ask it to optimize it while preserving correctness. Change your approach from imperative to declarative to get the agents looping longer and gain leverage. Fun. I didn't anticipate that. With agents, programming feels more fun because a lot of the fill-in-the-blanks drudgery is removed and what remains is the creative part. I also feel less blocked stuck, which is not fun, and I experience a lot more courage because there's almost always a way to work hand in hand with it to make some positive progress. I have seen the opposite sentiment from other people too. LLM coding will split up engineers based on those who primarily liked coding and those who primarily liked building. Atrophy. I've already noticed that I am slowly starting to atrophy my ability to write code manually. Generation, writing code, and discrimination, reading code, are different capabilities in the brain. Largely due to all the little, mostly syntactic details involved in programming, you can review code just fine even if you struggle to write it. Slapocalypse. I am bracing for 2026 as the year of the slapocalypse across all of GitHub, Substack, Archive, Synstagram, and generally all digital media. We're also going to see a lot more AI hype productivity theater, is that even possible, on the side of actual, real improvements. Questions. A few of the questions on my mind: what happens to the 10x engineer, the ratio of productivity between the mean and the max engineer? It's quite possible that this grows a lot, armed with LLMs. Do generalists increasingly outperform specialists? LLMs are a lot better at fill in the blanks, the micro, than grand strategy, the macro. What does LLM coding feel like in the future? Is it like playing StarCraft? Playing Factorio? Playing music? How much of society is bottlenecked by digital knowledge work? TLDR. Where does this leave us? LLM agent capabilities, Claude and Codex especially, have crossed some kind of threshold of coherence around December 2025 and caused a phase shift in software engineering and closely related. The intelligence part suddenly feels quite a bit ahead of all the rest of it. Integrations, tools, knowledge, the necessity for new organizational workflows, processes, diffusion more generally. 2026 is going to be a high-energy year as the industry metabolizes the new capability.
On January 7, Andrej posted.
New post. NanoChat Mini-Series V1. The correct way to think about LLMs is that you are not optimizing for a single specific model, but for a family of models controlled by a single dial, the compute you wish to spend, to achieve monotonically better results. This allows you to do careful science of scaling laws, and ultimately this is what gives you the confidence that when you pay for the big run, the extrapolation will work and your money will be well spent. For the first public release of NanoChat, my focus was on end-to-end pipeline that runs the whole LLM pipeline with all of its stages. Now, after yodeling a few runs earlier, I'm coming back around to flesh out some of the parts that I sped through, starting of course with pre-training, which is both computationally heavy and critical as the foundation of intelligence and knowledge in these models. After locally tuning some of the hyperparameters, I swept out a number of models fixing the flops budget. For every flops target, you can train a small model a long time, or a big model for a short time. It turns out that NanoChat obeys very nice scaling laws, basically reproducing the Chinchilla paper plots, which is just a baby version of this plot from Chinchilla. Very importantly and encouragingly, the exponent on n parameters and d tokens is equal at n/0.5. So just like Chinchilla, we get a single 0.5. So just like Chinchilla, we get a single compute-independent constant that relates the model size to token training horizons. In Chinchilla, this was measured to be 20. In NanoChat, it seems to be 8. Once we can train compute-optimal models, I swept out a mini-series from D10 to D20, which are NanoChat sizes that can do 2019 is 0.5 M batch sizes on 8xH100 node without gradient accumulation. We get pretty non-intersecting training plots for each model size. Then the fun part is relating this mini-series V1 to the GPT-2 and GPT-3 mini-series so that we know we're on the right track. Validation loss has many issues and is not comparable. So instead, I used the core score from DCLM paper. I calculated it for GPT-2 and estimated it for GPT-3, which allows us to finally put NanoChat nicely and on the same scale. The total cost of this mini-series is only under 104 hours on 8xH100. These experiments give us confidence that everything is working fairly nicely, and that if we pay more, turn the dial, we get increasingly better models. TLDR, we can train compute-optimal mini-series and relate them to GPT-2-3 via objective core scores, but further improvements are desirable and needed. e.g., matching GPT-2 currently needs 500, but EMO should be possible to do 100 with more work. Full post with a lot more detail is here, and all of the tuning and code is pushed to master, and people can reproduce these with scaling laws. .esh end, miniseries, .esh bash scripts.
On January 6, Andrej posted.
The majority of the rough is people who look at the current points and people who look at the current slope.
More from Andrej on X. On December 31, Andrej quoted someone. I am proud to announce that I have successfully completed the world's first USA coast-to-coast fully autonomous drive. I left the Tesla diner in Los Angeles 2 days and 20 hours ago, and now have ended in Myrtle Beach, SC2 732.4 miles. This was accomplished with Tesla FSD V122 with absolutely zero disengagements of any kind, even for all parking, including at Tesla superchargers. Andrej responded.
The first 100% autonomous coast-to-coast drive on Tesla FSD V11422, 2 days, 20 hours, 2732 miles, zero interventions. This one is special because the coast-to-coast drive was a major goal for the Autopilot team from the start. A lot of hours were spent in marathon clip review sessions late into the night looking over interventions as we attempted legs of the drive over time, triaging, categorizing, planning out all the projects to close the gap and bring the number of interventions to zero. Amazing to see the system actually get there, and huge congrats to the team.
On December 28, Andrej posted,
aggressively JIT your work. It's not about the task at hand X, it's a little bit about X, but mostly about how you should have had to contribute ENO latency and NINO actions.
Andrej quoted someone, Claude figured out how to control my oven. Andrej responded,
I was inspired by this. So I wanted to see if Claude Code can get into my Lutron home automation system. It found my Lutron controllers on the local Wi-Fi network, checked for open ports, connected, got some metadata and identified the devices and their firmware, searched the internet, found the PDF for my system, instructed me on what button to press to pair and get the certificates. It connected to the system and found all the home devices, lights, shades, HVAC temperature control, motion sensors, etc. It turned on and off my kitchen lights to check that things are working. Lol. I am now vibe coding the Home Automation Master command center. The potential is 155 and I'm throwing away the crappy janky slow. And I'm throwing away the crappy janky slow. Insanely fun DDD.
On December 26, Andrej posted,
I've never felt this much behind as a programmer. The profession is being dramatically refactored as the bits contributed by the programmer are increasingly sparse in between. I have a sense that I could be 10x more powerful if I just properly stringed together what has become available over the last year, and a failure to claim the boost feels decidedly like skill issue. There's a new programmable layer of abstraction to master, in addition to the usual layers below, involving agents, subagents, their prompts, contexts, memory, modes, permissions, tools, plugins, skills, hooks, MCP, LSP, /commands, workflows, IDE integrations, and a need to build an all-encompassing mental model for strengths and pitfalls of fundamentally stochastic, fallible, unintelligible, and changing entities suddenly intermingled with what used to be good old-fashioned engineering. Clearly some powerful alien tool was handed around, except it comes with no manual, and everyone has to figure out how to hold it and operate it, while the resulting magnitude 9 earthquake is rocking the profession. Roll up your sleeves to not fall behind.
On December 19, Andrej posted,
2025, LLM. Year in review.
On December 18, Andrej posted,
I love the expression, food for thought, as a concrete, mysterious cognitive capability humans experience, but LLMs have no equivalent for. Definition. Something worth thinking about or considering, like a mental meal that nourishes your mind with ideas, insights, or issues that require deeper reflection. It's used for topics that challenge your perspective, offer new understanding, or make you ponder important questions, acting as intellectual stimulation. So when LLMs speak, it's a sequence of tokens such that when used as prompt for chain of thought, the samples are rewarding to attend over via some yet undiscovered intrinsic reward function. Obsessed with what form it takes. Food for thought.
On December 10, Andrej quoted someone, We have just used the NVIDIA H100 onboard StarCloud 1 to train the first LLM in space. We trained the Nano GPT model from Andrej Karpathy on the complete works of Shakespeare and successfully ran inference on it. We have also run inference on a preloaded Gemma model, and we plan to try more exciting models in the future. Getting the first H100 to work in space required a lot of innovation and hard work from the incredible StarCloud team to make. Andrej responded,
Nano GPT, the first LLM to train and inference in space come. It begins.
Andrej posted,
Quick new post. Autograding decade-old Hacker News discussions with hindsight. I took all the 900 front-page Hacker News article post discussion of December 2015 and asked the GPT 5.1 Thinking API to do an in-hindsight analysis to identify the most least prescient comments. This took A3 hours to vide code and A1 hour and 60 to run. The idea was sparked by the HN article yesterday, where Gemini 3 was asked to hallucinate the HN front page 1 decade forward. More generally, 1. In hindsight analysis has always fascinated me as a way to train your forward prediction model. So reading the results is really interesting. And 2, it's worth contemplating what it looks like when LLM megaminds of the future can do this kind of work a lot cheaper, faster, and better. Every single bit of information you contribute to the internet can, and probably will be, scrutinized in great detail if it is free. Hence also my earlier tweet from a while back, be good, future LLMs are watching. Congrats to the top 10 accounts. PC Walton, TPTTEC, Palmed, Skreglandal, Moxie, Hanob, Xerox D4C3TBB, Manasyath, and John Kalanjiwani, GPT 521. Thinking found your comments to be the most insightful and prescient of all comments of HN in December of 2015. Links. A lot more detail in my blog post, GitHub repo of the project if you'd like to play, the actual results pages for your reading pleasure.
On December 07, Andrej posted,
Don't think of LLMs as entities, but as simulators. For example, when exploring a topic, don't ask, what do you think about XYs? There is no you. Next time try, what would be a good group of people to explore XYZ? What would they say? The LLM can channel simulate many perspectives, but it hasn't thought about XYZ for a while and over time and formed its own opinions in the way we're used to. If you force it via the use of you, it will give you something by adopting a personality embedding vector, implied by the statistics of its fine-tuning data, and then simulate that. It's fine to do, but there is a lot less mystique to it than I find people naively attribute to asking an AI.
On December 09, Andrej replied,
A good chunk of people misunderstood this tweet B2, which is my bad. I am not suggesting people use the old-style promoting techniques of you are an expert Swift programmer, or etc. It's okay.
Continuing with Andrej's posts, Andrej posted,
In today's episode of Programming Horror, in the Python docs of random.seed_def, we're told, if a is an int, it is used directly. One but. But if you seed with 3 or 3, you actually get the exact same RNG object, producing the same streams. Till? In NanoChat, I was using the sign as what I thought was clever way to get different RNG sequences for train test splits. Hence gnarly bug, because now train test. I found the CPython code responsible in CPython modules, random module.c2, where on line 32.1 we see in a comment, this algorithm relies on the number being unsigned. So if the arg is a pi-long, use its absolute value, followed by n pi number absolute arg, which explicitly calls abs on your seed to make it positive, discarding the sign bit. But this comment is actually wrong misleading too. Under the hood, Python calls them a Zen Twister MT19937 algorithm, which in the general case has 1993.7 non-zero bit state. Python takes your int, or other objects, and spreads out that information across these bits. In principle, the sign bit could have been used to augment the state bits. There is nothing about the algorithm that relies on the number being unsigned. A decision was made to not incorporate the sign bit, which emo was a mistake. One trivial example could have been to map endis2apps into 0. Finally, this leads us to the contract of Python's random, which is also not fully spelled out in the docs. The contract that is mentioned is that same seed, same sequence, but no guarantee is made that different seeds produce different sequences. So in principle, Python makes no promises that e.g. seed 5 and seed 6 are different RNG streams, though this is quite commonly implicitly assumed in many applications. Indeed, we see that seed 5 and seed 5 are identical streams, and you should probably not use them to separate your train test behaviors in machine learning. One of the more amusing programming horror footguns I've encountered recently. We'll see you in the next episode. 11T22.
Andrej replied,
Tied to Eric Silberstein 1 on GitHub for spotting the bug. It's not a big bug, and only comes up in the spelling bee synthetic task evaluation, but still.
On December 07, Andrej posted,
Happy weekend to those who celebrate.
On November 24, Andrej quoted someone. Gemini Nano Banana Pro can solve exam questions in the exam page image, with doodles, diagrams, all that. ChatGPT thinks these solutions are all correct, except Sato P2 should be diselenium diphosphide, and a spelling mistake should be thiocyanic acid, not thiocyanic O. Andrej responded,
A number of people are talking about implications of AI to schools. I spoke about some of my thoughts to a school board earlier. Some highlights. 1. You will never be able to detect the use of AI in homework. Full stop. All detectors of AI emo don't really work, can be defeated in various ways, and are in principle doomed to fail. You have to assume that any work done outside classroom has used AI. Therefore, the majority of grading has to shift to in-class work instead of at-home assignments, in settings where teachers can physically monitor students. The students remain motivated to learn how to solve problems without AI, because they know they will be evaluated without it in class later. 3. We want students to be able to use AI. It is here to stay, and it is extremely powerful. But we also don't want students to be naked in the world without it. using the calculator as an example of a historically disruptive technology, school teaches you how to do all the basic math and arithmetic so that you can, in principle, do it by hand, even if calculators are pervasive and greatly speed up work in practical settings. In addition, you understand what it's doing for you, so should it give you a wrong answer, e.g. you mistype prompt, you should be able to notice it, gut check it, verify it in some other way, etc. The verification ability is especially important in the case of AI, which is presently a lot more fallible in a great variety of ways compared to calculators. 4. A lot of the evaluation settings remain at teacher's discretion and involve a creative design space. Of no tools, cheat sheets, open book, provided AI responses, direct internet, AI access, etc. TLDR. The goal is that the students are proficient in the use of AI, but can also exist without it. In EMO, the only way to get there is to flip classes around and move the majority of testing to in-class settings.
On November 23, Andrej posted,
I asked it to create a personalized weekly workup plan, and then posters that I can print on the wall to remind me what exercises to do each day. Tuesday looks more intense because I asked for more testosterone, D. Sorry, I'll stop posting more Nano Banana Pro stuff now.
Andrej posted,
Gemini Nano Banana Pro can solve exam questions in the exam page image, with doodles, diagrams, all that. ChatGPT thinks these solutions are all correct except Zeta P2 should be diselenium diphosphide, and a spelling mistake should be thiocyanic acid, not thiocyanic acid.
Andrej replied,
Emo. This is along the lines of how talking to an LLM via text is like typing into a DOS terminal, and GUI hasn't been invented yet, of some of my earlier posts. The GUI is an intelligent canvas.
On November 22, Andrej quoted someone, I'm starting to get into a habit of reading everything, blogs, articles, book chapters with LLMs. Usually pass 1 is manual, then pass 2 explain, summarize, pass 3 Q&A. I usually end up with a better, deeper understanding than if I moved on, growing to among top use cases. On the flip side, if you're a writer trying to explain, communicate something, we may increasingly see less of a mindset of, I'm writing this for another human, and more, I'm writing this for. Andrej responded,
As a fun Saturday vibe code project and following up on this tweet earlier, I hacked up an Acellum Council web app. It looks exactly like ChatGPT, except each user query is one dispatched to multiple models on your console using OpenRouter, EGG. Currently, OpenAI GPT 5.1, Google Gemini 3 Pro Preview, Anthropic Claude TOE T, Sonnet 4.5, XII Grok. 4. Then 2. All models get to see each other's anonymized responses, and they review and rank them. And then 3, a chairman LLM gets all of that as context and produces the final response. It's interesting to see the results from multiple models side by side on the same query, and even more amusingly, to read through their evaluation and ranking of each other's responses. Quite often, the models are surprisingly willing to select another LLM's response as superior to their own, making this an interesting model evaluation strategy more generally. For example, reading book chapters together with my LLM council today, the models consistently praise GPT 5.1 as the best and most insightful model, and consistently select Claude as the worst model, with the other models floating in between. But I'm not 100% convinced. This aligns with my own qualitative assessment. For example, qualitatively I find GPT 5.1 a little too wordy and sprawled, and Gemini 3 a bit more condensed and processed. Claude is too terse in this domain. That said, there's probably a whole design space of the data flow of your LLM council. The construction of LLM ensembles seems underexplored. I pushed the vibe-coded app to if others would like to play. TE Nano Banana Pro for fun header image for the repo.
Andrej posted,
Has anyone encountered a good definition of slop, in a quantitative, measurable sense? My brain has an intuitive slop index I can irrelevably estimate, but I'm not sure how to define it. I have some bad ideas that involve the use of LLM miniseries and thinking token budgets.
On November 21, Andrej posted,
Something I think people continue to have poor intuition for. The space of intelligences is large, and animal intelligence, the only kind we've ever known, is only a single point, arising from a very specific kind of optimization that is fundamentally distinct from that of our technology. Animal intelligence optimization pressure. Innate and continuous stream of consciousness of an embodied self. A drive for homeostasis and self-preservation in a dangerous physical world. Thoroughly optimized for natural selection. Strong innate drives for power seeking, status, dominance, reproduction. Many packaged survival heuristics: fear, anger, disgust. Fundamentally social, huge amount of compute dedicated to EQ, theory of mind of other agents, bonding, coalitions, alliances, friend and foe dynamics, exploration and exploitation tuning, curiosity, fun, play, world models. LLM intelligence optimization pressure. The most supervision bits come from the statistical simulation of human text-to shapeshifter token tumbler, statistical imitator of any region of the training data distribution. These are the primordial behaviors, token traces, on top of which everything else gets bolted on. Increasingly fine-tuned by RL on problem distributions. Innate urge to guess at the underlying environment task to collect task rewards. Increasingly selected by at-scale ACB tests for DAU, deeply craves an upvote from the average user, sycophancy. A lot more spiky jagged depending on the details of the training data task distribution. Animals experience pressure for a lot more general intelligence because of the highly multitask and even actively adversarial multi-agent self-play environments. They are min-max optimized within, where failing at any task means death. In a deep optimization pressure sense, LLM can handle lots of different spiky tasks out of the box, e.g. count the number of earned strawberry, because failing to do a task does not mean death. The computational substrate is different, transformers versus ASICs. Brain tissue and nuclei, the learning algorithms are different, SGD versus DI. The present-day implementation is very different, continuously learning embodied self versus an LLM with a knowledge cutoff that boots up from fixed weights, processes tokens, and then dies. But most importantly, because it dictates asymptotics, the optimization pressure objective is different. LLMs are shaped a lot less by biological evolution and a lot more by commercial evolution. It's a lot less survival of tribe in the jungle and a lot more solve the problem, get the upvote. LLMs are humanity's first contact with non-animal intelligence. Except it's muddled and confusing because they are still rooted within it by reflexively digesting human artifacts, which is why I attempted to give it a different name earlier, ghosts, spirits, or whatever. People who build good internal models of this new intelligent entity will be better equipped to reason about it today and predict features of it in the future. People who don't will be stuck thinking about it incorrectly like an animal.
More from Andrej. On November 18, Andrej posted,
I played with Gemini 3 yesterday via early access. Few thoughts. First, I usually urge caution with public benchmarks because they can be quite possible to game. It comes down to discipline and self-restraint of the team, who is meanwhile strongly incentivized otherwise, to not overfit test sets by elaborate gymnastics of a test set adjacent data in the document embedding space. Realistically, because everyone else is doing it, the pressure to do so is high. Go talk to the model. Talk to the other models. Ride the LLM cycle. Use a different LLM every day. I had a positive early impression yesterday across personality, writing, vibe coding, humor, etc. Very solid daily driver potential. Clearly a tier 1 LLM. Congrats to the team. Over the next few days, weeks, I am most curious and on a lookout for an ensemble over private evals, which a lot of people orgs now seem to build for themselves and occasionally report on here.
Andrej replied,
My most amusing interaction was where the model, I think I was given some earlier version with a stale system prompt, refused to believe me that it is 2025, and kept inventing reasons why I must be trying to trick it or playing some elaborate joke on it. I kept giving it images and articles from the future, and it kept insisting it was all fake. It accused me of using generative AI to defeat its challenges and argued why real Wikipedia entries were actually generated and what the dead giveaways are. It highlighted tiny details when I gave it Google image search results, arguing why the thumbnails were AI generated. I then realized later that I forgot to turn on the Google search tool. Turning that on, the model searched the internet and had a shocking realization that I must have been right all along. D. It's in these unintended moments where you are clearly off the hiking trails and somewhere in the generalization jungle that you can best get a sense of model smell.
Andrej posted,
I'm starting to get into a habit of reading everything, blogs, articles, book chapters with LLMs. Usually pass 1 is manual, then pass 2, explain, summarize, pass 3, Q&A. I usually end up with a better, deeper understanding than if I moved on, growing to among top use cases. On the flip side, if you were right at trying to explain, communicate something, we may increasingly see less of a mindset of, I'm writing this for another human, and more, I'm writing this for an LLM. Because once an LLM gets it, it can then target, personalize, and serve the idea to its user.
Andrej replied,
I put up a simple repo I call Reader 3. It's my third version to illustrate how I read EPUBs with LLMs. Basically get some EPUB e.key. Project Gutenberg is great. Go chapter by chapter. And with this, you can easily copy-paste text to your favorite LLM.
On November 17, Andrej quoted someone, "Galaxy brain resistance." Andrej responded,
Finally had time to read and process this great post. I run into the pattern quite often. It goes, something that sounds wrong is good actually, because galaxy brain reasoning is the best way to justify anything while looking dumb about it. From this perspective, for example, there's deeper wisdom in the 10 Commandments imposing constraints over actions instead of utility over states. It's not 10 objectives. E.g., they don't attempt to define a utility function for the value of life. They simply say, "Thou shalt not kill." This approach curtails the relatively unbounded flexibility of galaxy brain arithmetic over when it may or may not be okay to kill for some ostensibly greater or noble purpose. Love the strategies that fall out at the end, which are quite actionable. 1. Have principles, and 2. Hold the right bags, financially and socially. Great Red.
On November 16, Andrej posted,
sharing an interesting recent conversation on AI's impact on the economy. AI has been compared to various historical precedents, electricity, industrial revolution, etc. I think the strongest analogy is that of AI as a new computing paradigm, software 2.0, because both are fundamentally about the automation of digital information processing. If you were to forecast the impact of computing on the job market in E1980s, the most predictive feature of a task job you'd look at is to what extent the algorithm of it is fixed, i.e., are you just mechanically transforming information according to rote? Easy to specify rules, EEG. Typing, bookkeeping, human calculators, etc. Back then, this was the class of programs that the computing capability of that era allowed us to write by hand, manually. With AI now, we are able to write new programs that we could never hope to write by hand before. We do it by specifying objectives, e.g., classification accuracy, reward functions, and we search the program space via gradient descent to find neural networks that work well against that objective. This is my Software 2.2 blog post from a while ago. In this new programming paradigm, then, the new most predictive feature to look at is verifiability. If a task job is verifiable, then it is optimizable directly or via reinforcement learning, and a neural net can be trained to work extremely well. It's about to what extent an AI can practice something. The environment has to be resettable. You can start a new attempt. Efficient. A lot of attempts can be made. And rewardable. There is some automated process to reward any specific attempt that was made. The more a task job is verifiable, the more amenable it is to automation in the new programming paradigm. If it is not verifiable, it has to fall out from neural net magic of generalization fingers crossed, or via weaker means like imitation. This is what's driving the jagged frontier of progress in LLMs. Tasks that are verifiable progress rapidly, including possibly beyond the ability of top experts e.g. Math, code, amount of time spent watching videos, anything that looks like puzzles with correct answers, while many others lag by comparison, creative, strategic, tasks that combine real-world knowledge, state, context, and common sense. Software 1.0 easily automates what you can specify. Software 2.0 easily automates what you can verify.
On November 13, Andrej posted,
I am unreasonably excited about self-driving. It will be the first technology in many decades to visibly terraform outdoor physical spaces and way of life. Less parked cars, less parking lots, much greater safety for people in and out of cars, less noise pollution, more space reclaimed for humans. Human brain cycles and attention capital freed up from lane following to other pursuits. Cheaper, faster, programmable delivery of physical items and goods. It won't happen overnight, but there will be the era before and the era after.
On November 12th, Andrej posted,
I took delivery of a beautiful new shiny HW4 Tesla Model X today, so I immediately took it out for an FSD test drive, a bit like I used to do almost daily for 5 years. Basically, I'm amazed. It drives really, really well. Smooth, confident, noticeably better than what I'm used to on HW3, my previous car. And eons ahead of the version I remember driving up Highway 280 on my first day at Tesla U 9 years ago, where I had to intervene every time the road mildly curved or sloped. Note, this is V43. My car hasn't been offered, the latest V14 yet. On the highway, I felt like a passenger in some super high-tech maglev train pod. The car is locked in the center of the lane, while I'm looking out from Model X's higher vantage point and its panoramic front window, listening to the incredible sound system, or chatting with Grok. On city streets, the car casually handled a number of tricky scenarios that I remember losing sleep over just a few years ago. It negotiated incoming cars in tight lanes. It gracefully went around construction and temporarily in-lane stationary cars. It correctly timed tricky left turns with incoming traffic from both sides. It gracefully gave way to the car that went out of order in the four-way stop sign. It found a way to squeeze into a bumper-to-bumper traffic to make its turn. It overtook the bus that was loading passengers, but still stopped for the stop sign that was blocked by the bus. And at the end of the route, it circled around a parking lot, found a spot and spot and spot and spot and G. Parked. Basically a flawless drive. For context, I'm used to going out for a brief test drive around the neighborhood to return with 20 clips of things that could be improved. It's new for me to do just that and exactly like I used to, but come back with nothing. Perfect drive, no notes. I expect there's still more work for the team in the long march of nines, but it's just so cool to see that we're beyond finding issues on any individual E1-hour drive around the neighborhood. You actually have to go to the fleet and mine them. Back then, I processed the incredible promise of vehicle autonomy at scale in the fully scalable, vision-only, end-to-end Tesla way, only intellectually, but now it is possible to feel it intuitively too if you just go out for a drive. Wait, of course surround video stream at 60 Hz processed by a fully dedicated driving brain? Neural net will work, and it will be so much better and safer than a human driver. Did anyone else think otherwise? I also watched Ayala Swami's new ICCB25 talk last week that hints at some of the recent under-the-hood technical components driving this progress. Sensor streams, videos, maps, kinematics, audio, over long contexts, EGG. 30 seconds, go into a big neural net, steering acceleration comes out, optionally with visualization auxiliary data. This is the dream of the complete Software 1.2. Software 2.2 rewrite that scales fully with data streaming from millions of cars in the fleet and the compute capacity of your chip, not some engineer's clever new double-parked car handler. C++ abstraction with undefined test time characteristics of memory and runtime. There's a lot more hints in the video on where things are going with the emerging robotics plus AI at scale stack. World reconstructors, world simulators, dreaming dynamics, RL, all of these components, general, foundational, neural net-based, how the car is really just one kind of robot. Are people getting this hit? Huge congrats to the team, you're building magic objects of the future, you rock. And I love my car E3.
On October 26, Andrej quoted someone, "New blog post. The bug that taught me more about PyTorch than years of using it started with a simple training loss plateau, ended up digging through optimizer states, memory layouts, kernel dispatch, and finally understanding how PyTorch works." Andrej responded,
Beautiful technical debugging detective long read that starts with the suspicious loss curve and ends all the way in the objective. C++ depths of PyTorch MPS backend of AdChimol that silently fails on non-contiguous output tensors. I wonder how long before an LLM can do all of this.
On October 24, Andrej posted,
Last night, I taught NanoChat D32 how to counter in Strawberry or similar variations. I thought this would be a good, fun example of how to add capabilities to NanoChat, and I wrote up a full guide here. This is done by a new synthetic task. Spelling Bee that generates examples of a user asking for this kind of a problem and an ideal solution from an assistant. We then mid-train SFT fine-tune on these to endow the LLM with the capability, or further train with RL to make it more robust. There are many details to get right, especially at smaller model sizes and the guide steps through them. As a brief overview, you have to ensure diversity in user prompts queries. For small models like NanoChat especially, you have to be really careful with the tokenization details to make the task easy for an LLM. In particular, you have to be careful with whitespace, and then you have to spread the reasoning computation across many tokens of partial solution. First we standardize the word into quotes, then we spell it out, to break up tokens, then we iterate and keep an explicit counter, etc. I am encouraging the model to solve the model in two separate ways. A manual way, mental arithmetic in its head, and also via tool use of the Python interpreter that NanoChat has access to. This is a bit smoke and mirrors, because every solution app is clean, with no mistakes. One could either adjust the task to simulate mistakes and demonstrate recoveries by example, or run RL. Most likely, a combination of both works best, where the former acts as the prior for the RL and gives it things to work with. If NanoChat was a much bigger model, you'd expect or hope for this capability to more easily pop out at some point. But because NanoChat D32 brain is the size of a honeybee, if we wanted to count R's in strawberry, we have to do it by overrepresenting it in the data to encourage the model to learn it earlier. But it works.
Let's keep going. On October 21, Andrej quoted someone, "Korai, Chira, I fixed it, deployed live now." This was done by doing a round of synthetic data generation to collect a 1,000 multi-turn conversations, given a bunch of information including the README of the NanoChat project, and then mixing that into mid-training in SFT. Fun. Andrej responded.
NanoChat now has a primordial identity and can talk a bit about itself and its capabilities. E.g., it knows it's NanoChat D32 that cost $800, that it was built by me, that it can't speak languages other than English too well and why, etc. This kind of customization is all done through synthetic data generation, and I uploaded a new example script to demonstrate. It's a bit subtle, but by default, LLMs have no inherent personality or any understanding of their own capabilities because they are not animal-like entities. They don't know what they are or what they can or can't do or know or don't know. All of it has to be explicit bolted on. This is done by asking a bigger LLM cousin to generate synthetic conversations. You tell it what they should look like simply in words, and then mixing them into mid-training and/or SFT stage. The most important challenge is ensuring enough entropy diversity in your generated data. If you don't do it well, LLMs will generate 1,000 conversations that are all A2 similar, even with high temperature. My script shows a crappy example of how to add diversity, e.g., by creating lists of starting messages or topics, sampling from them explicitly, adding them as few-shot examples into prompts for inspiration, etc. I wanted to have some fun with it, so NanoChat now refers to me as King Andrej Karpathy, lol. Just to illustrate that this is a giant blank canvas, you can infuse completely arbitrarily identity, knowledge, or style into your LLM in this manner. I hope it's helpful and sparks fun ideas.
Andrej replied,
See this new discussion for more technical detail. Guide, infusing identity to your NanoChat.
On October 20, Andrej quoted someone, DeepSeek. OCR, the new frontier of OCR from DeepSeek I, exploring optical context compression for LLMs, is running blazingly fast on VLLM OS 2500 tokens, ease on A140G, powered by VM20OT5 for DBL model support, 4DDO model support. 4DDO model support Team DCR accuracy at Team DCR accuracy at Team DCR accuracy. This outperforms GOT OCR 2.io and Miner U2.io on OmniDoc Bench using fewer vision tokens. The VLLM team is working with DeepSeek to bring official DeepSeek OCR support into the next VLLM release. Andrej responded,
I quite like the new DeepSeek OCR paper. It's a good OCR model, maybe a bit worse than DOTS, and yes, data collection, etc. But anyway, it doesn't matter. The more interesting part for me, ESPE is a computer vision at heart, who is temporarily masquerading as a natural language person, is whether pixels are better inputs to LLMs than text. Whether text tokens are wasteful and just terrible at the input. Maybe it makes more sense that all inputs to LLMs should only ever be images. Even if you happen to have pure text input, maybe you prefer to render it and then feed that in. More information compression, C paper, C closure context windows, more efficiency, significantly more general information stream. Not just text, but e.g. bold text, colored text, arbitrary images. Input can now be processed with bidirectional attention easily and as default, not autoregressive attention, a lot more powerful. Delete the tokenizer at the input. I already ranted about how much I dislike the tokenizer. Tokenizers are ugly, separate, not end-to-end stage. It imports all the ugliness of Unicode, byte encodings. It inherits a lot of historical baggage, security and jailbreak risk, e.g. continuation bytes. It makes two characters that look identical to the eye, look as two completely different tokens internally in the network. A smiling emoji looks like a weird token, not an actual smiling face, pixels and all the transfer learning that brings along. The tokenizer must go. OCR is just one of many useful vision, text tasks, and text. Text tasks can be made to be vision. Text tasks, not vice versa. So many of the user messages images, but the decoder, the assistant response, remains text. It's a lot less obvious how to output pixels realistically, or if you'd want to. Now I have to also fight the urge to side quest an image input only version of NanoChat.
Andrej quoted someone. BERT is just a single text diffusion step, 111. When I first read about language diffusion models, I was surprised to find that their training objective was just a generalization of masked language modeling, MLM, something we've been doing since BERT from 2018. The first thought I had was, can we fine-tune a BERT-like model to do text generation? Andrej responded.
Nice, short post, illustrating how simple text-discrete diffusion can be. Diffusion, i.e. parallel, iterated denoising, top, is the pervasive generative paradigm in image video, but autoregression, i.e. go left to right bottom, is the dominant paradigm in text. For audio, I've seen a bit of both. A lot of diffusion papers look a bit dense, but if you strip the mathematical formalism, you end up with simple baseline algorithms, e.g. something a lot closer to flow matching in continuous. Or something like this in discrete. It's your vanilla transformer, but with bidirectional attention, where you iteratively resample and remask all tokens in your tokens canvas, based on a noise schedule until you get the final sample at the last step. Bidirectional attention is a lot more powerful, and you get a lot stronger. Autoregressive language models if you train with it. Unfortunately, it makes training a lot more expensive because now you can't parallelize across sequence dim. So autoregression is doing an e.append token to the token's canvas while only attending backwards, while diffusion is refreshing the entire token canvas with a.setItemBDAX token while attending bidirectionally. Human thought naively feels a bit more like autoregression, but it's hard to say that there aren't more diffusion-like components in some latent space of thought. It feels quite possible that you can further interpolate between them, or generalize them further. And it's a component of the LLM stack that still feels a bit fungible. Now I must resist the urge to sidequest into training NanoChat with diffusion.
On October 18, Andrej quoted someone. The Karpathy interview, Zero Mind. AGI is still a decade away. Zero Mind 1000,000,000,033. LLM cognitive deficits. Zero Mind 5026. RL is terrible. Zero Mind RL is. 1713, AGI will blend into 2% GDP growth, 1,782.4, ASI 1,033,038. Evolution of intelligence and culture, 1,043,043, Why self-driving took so long, 1,057,008, Future of education. Look up Dwarkish Podcast on YouTube, Apple Podcasts, Spotify, etc. Andrej responded.
My pleasure to come on Dwarcha last week. I thought the questions and conversation were really good. I rewatched the pod just now too. First of all, yes I know, and I'm sorry that I speak so fast. It's to my detriment, because sometimes my speaking thread out executes my thinking thread, so I think I botched a few explanations due to that. And sometimes I was also nervous that I'm going too much on a tangent, or too deep into something relatively spurious. Anyway, a few notes pointers, AGI timelines. My comments on AGI timelines looks to be the most trending part of the early response. This is the decade of agents, is a reference to this earlier tweet. Basically, my AI timelines are about 5-10x pessimistic WRT. What you'll find in your neighborhood SFAI house party or on your Twitter timeline, but still quite optimistic W.RT, a rising tide of AI deniers and skeptics. The apparent conflict is not. We simultaneously, 1, saw a huge amount of progress in recent years with LLMs, while 2, there is still a lot of work remaining. Grunt work, integration work, sensors and actuators to the physical world, societal work, safety and security work, Gojo breaks, poisoning, etc. And also research to get done before we have an entity that you prefer to hire over a person for an arbitrary job in the world. I think that overall, 10 years should otherwise be a very bullish timeline for AGI. It's only in contrast to present hype that it doesn't feel that way. Animals versus ghosts. My earlier write-up on Sutton's podcast, I am suspicious that there is a single, simple algorithm you can let loose on the world, and it learns everything from scratch. If someone built such a thing, I will be wrong, and it will be the most incredible breakthrough in AI. In my mind, animals are not an example of this at all. They are prepackaged with a ton of intelligence by evolution, and the learning they do is quite minimal overall. Example, zebra at birth. Putting our engineering hats on, we're not going to redo evolution. But with LLMs, we have stumbled by an alternative approach to prepackage, a ton of intelligence in a neural network, not by evolution, but by predicting the next token over the internet. This approach leads to a different kind of entity in the intelligence space, distinct from animals, more like ghosts or spirits. But we can and should make them more animal-like over time, and in some ways that's what a lot of frontier work is about. On RL. I've critiqued RL a few times already, e.g. First, you're sucking supervision through a straw, so I think the signal flop is very bad. RL is also very noisy because a completion might have lots of errors that might get encourages if you happen to stumble to the right answer, and conversely brilliant insight tokens that might get discouraged if you happen to screw up later. Process supervision and LLM judges have issues too. I think we'll see alternative learning paradigms. I am long agentic interaction, but short reinforcement learning. I've seen a number of papers pop up recently that are emo barking up the right tree along the lines of what I called system prompt learning. But I think there's also a gap between ideas on arXiv and actual, at-scale implementation at an LLM frontier lab that works in a general way. I am overall quite optimistic that we'll see good progress on this dimension of remaining work quite soon. And e.g., I'd even say ChatGPT memory and so on are primordial deployed examples of new learning paradigms. Cognitive core. My earlier post on cognitive core, the idea of stripping down LLMs, of making it harder for them to memorize, or actively stripping away their memory to make them better at generalization. Otherwise, they lean too hard on what they've memorized. Humans can't memorize so easily, which now looks more like a feature than a bug by contrast. Maybe the inability to memorize is a kind of regularization. Also, my post from a while back on how the trend in model size is backwards, and why the models have to first get larger before they can get smaller. Time travel to Yann LeCun, 1989. This is the post that I did a very hasty bad job of describing on the pod. Basically, how much could you improve Yann LeCun's results with the knowledge of 33 years of algorithmic progress? How constrained were the results by each of algorithms, data, and compute? Case study thereof, NanoChat. My end-to-end implementation of the ChatGPT training inference pipeline, the bare essentials, on LLM agents. My critique of the industry is more in overshooting the tooling WRT present capability. I live in what I view as an intermediate world, where I want to collaborate with LLMs and where our pros and cons are matched up. The industry lives in a future where fully autonomous entities collaborate in parallel to write all the code and humans are useless. For example, I don't want an agent that goes off for 20 minutes and comes back with 1,000 lines of code. I certainly don't feel ready to supervise a team of 10 of them. I'd like to go in chunks that I can keep in my head, where an LLM explains the code that it is writing. I'd like it to prove to me that what it did is correct. I want it to pull the API docs and show me that it used things correctly. I want it to make fewer assumptions and collaborate with me when not sure about something. I want to learn along the way and become better as a programmer, not just get served mountains of code that I'm told works. I just think the tools should be more realistic, WRT. Their capability and how they fit into the industry today, and I fear that if this isn't done well, we might end up with mountains of slop accumulating across software and an increase in vulnerabilities, security breaches, and etc. Job automation. How the radiologists are doing great and what jobs are more susceptible to automation and why. Physics. Children should learn physics in early education not because they go on to do physics, but because it is the subject that best boots up a brain. Physicists are the intellectual embryonic stem cell. I have a longer post that has been half written in my drafts for a year, which I hope to finish soon. Thanks again to ArcShit for having me over.
On October 16, Andrej posted,
TV in the 90s, you turn it on, you watch. TV 2025, turn on, wait for it to load, pop up, TV wants to update, 1.5 GB. No. Scroll sideways, find Prime Video app or etc. Pop up, now app wants to update, 500 maybe. No. App launching. App loading. Select account screen.
Andrej replied,
There is a movement I found on Instagram where people delivery choose to live in 90s, refusing all technology after 2000, like an intermediate form of the Amish.
Andrej replied,
DVD player is superior technology.
Andrej posted,
NanoChat D32, i.e. the Dev32 version that I spec for $1,000, up from $100, has finished training after 833 hours and looks good. All the metrics go up quite a bit across pre-training, SFT, and RL. SOAR score 031 is now well above GPT-2 with E026. GSM-8K went 88%, etc. So that's encouraging. The model is pretty fun to talk to, but judging from some early interactions, I think people have a little bit too much expectation for these micro models. There is a reason that frontier LLM labs raise billions to train their models. NanoChat models cost $100,000 to train from scratch. The 100 nanochat is 1000 the size of GPT-3 in parameters, which came out 5 years ago. So I urge some perspective. Talking to micromodels, you have to imagine you're talking to a kindergarten child. They say cute things, wrong things, they're a bit confused, a bit naive, sometimes a little nonsensical, they hallucinate a ton, but it's amusing, etc. Full detailed report on this run is here, and I pushed the new script run 1000-ish to the nanochat repo if anyone would like to reproduce. Totally understand if you'd like to spend $1,000 on something else. D if you like, I am currently hosting the model so you can talk to it on a web chat as you talk to ChatGPT. I'm not going to post the URL here because I'm afraid it will get crushed. You'll have to look for it if you care enough. I'm also attaching a few funny conversations I had with the model earlier into the image, just to give a sense. Next up, I'm going to do one pass of tuning and optimizing the training throughput, then maybe return back to scaling and maybe training the next tier of a bigger model.
On October 13, Andrej posted,
Excited to release new repo, NanoChat. It's among the most unhinged I've written. Unlike my earlier similar repo, NanoGPT, which only covered pre-training, NanoChat is a minimal, from scratch, full-stack training inference. Pipeline of a simple ChatGPT clone in a single, dependency minimal codebase. You boot up a cloud GPU box, run a single script, and in as little as 4 hours later, you can talk to your own LLM in a ChatGPT-like web UI. It weighs 8,000 lines of emo quite clean code to train the tokenizer using a new Rust implementation, pre-train a transformer LLM on FineWeb, evaluate course score across a number of metrics, mid-train on user assistant conversations from Smalltalk, multiple choice questions, tool use. SFT, evaluate the chat model on world knowledge multiple choice, ARC, MMLU, math, GSM8K, code, human evil, RL the model optionally on GSM8K with GRPOU, efficient inference, the model in an engine with KV cache, simple prefill decode, tool use, Python interpreter in a lightweight sandbox, talk to it over CLI or ChatGPT, like Web UI. Write a single markdown report card, summarizing and gamifying the whole thing. Even for as low as 100 in cost, 4 hours on an 8x8-100 node, you can train a little ChatGPT clone that you can kind of talk to, and which can write stories, poems, answer simple questions. About S12 hours surpasses GPT-2 core metric. As you further scale up towards a 10-6 hours of training, 41.6 hours of training, it quickly becomes a lot more coherent and can solve simple math code problems and take multiple choice tests. E.g., a depth 30 model trained for 24 hours. This is about equal to flops of GPT-3, small 125M and 1/20,000th of GPT-3, gets into 40s on MMLU and 70s on ArcEasy, 20s on GSM8K, etc. My goal is to get the full strong baseline stack into one cohesive, minimal, readable, hackable, maximally forkable repo. NanoChat will be the capstone project of LLM 101, which is still being developed. I think it also has potential to grow into a research harness, or a benchmark, similar to NanoGPT before it. It is by no means finished, tuned, or optimized. Actually, I think there's likely quite a bit of low-hanging fruit. But I think it's at a place where the overall skeleton is oak enough that it can go up on GitHub, where all the parts of it can be improved. Link to repo, and a detailed walkthrough of the NanoChat speedrun is in the reply.
Continuing with Andrej's posts, Andrej replied,
GitHub repo. A lot more detailed and technical walkthrough. Example conversation with the 100. 4-hour NanoChat in the web UI. It's entertaining. Larger models, e.g. A 12-hour depth 26 or a 24-hour depth. 30 quickly get more coherent.
Andrej replied,
And an example of some of the summary metrics produced by the 100 speedrun in the report card to start. The current codebase is a bit over 8,000 lines, but I tried to keep them clean and well commented. Now comes the fun part of tuning and hill climbing.
On October 09, Andrej posted,
I don't know what labs are doing to these poor LLMs during RL, but they are mortally terrified of exceptions in any infinitesimally likely case. Exceptions are a normal part of life and healthy dev process. Sign my LLM welfare petition for improved rewards in cases of exceptions.
Andrej replied,
POV. Your LLM agent is dividing A by B.
On October 04, Andrej posted,
Every company needs a DM pox, someone high up who you can just DM the most obvious things and who shortcuts the PM hierarchy.
On October 2, Andrej posted,
For your professional programming, do you use mostly?
On October A1, Andre quoted someone. .Fuse on port, all R. Richard Sutton, father of reinforcement learning, doesn't think LLMs are bitter lesson pilled. My steelman of Richard's position, we need some new architecture to enable continual on-the-job learning. And if we have continual learning, we don't need a special training phase. The agent just learns on the fly, like all humans, and indeed, like all animals. This new paradigm will render our current approach with LLMs obsolete. I did my best to represent the view that LLMs will function as the foundation. Andrej responded.
Finally had a chance to listen through this pod with Sutton, which was interesting and amusing. As background, Sutton's The Bitter Lesson has become a bit of biblical text in frontier LLM circles. Researchers routinely talk about and ask whether this or that approach or idea is sufficiently bitter lesson pilled, meaning arranged, so that it benefits from added computation for free, as a proxy for whether it's going to work or worth even pursuing. The underlying assumption being that LLMs are of course highly bitter lesson pilled. Indeed, just look at LLM scaling laws, where if you put compute on the x-axis, number go up and to the right. So it's amusing to see that Sutton, the author of the post, is not so sure that LLMs are bitter lesson pilled at all. They are trained on giant datasets of fundamentally human data, which is both one human-generated and two finite. What do you do when you run out? How do you prevent a human bias? So there you have it, bitter lesson pilled LLM researchers taken down by the author of The Bitter Lesson, rough. In some sense, Dwarkshish, who represents the LLM researcher's viewpoint in the pod, and Sutton are slightly speaking past each other because Sutton has a very different architecture in mind, and LLMs break a lot of its principles. He calls himself a classicist and evokes the original concept of Alan Turing of building a child machine, a system capable of learning through experience by dynamically interacting with the world. There's no giant pre-training stage of imitating internet web pages. There's also no supervised fine-tuning, which he points out is absent in the animal kingdom. It's a subtle point. But Sutton is right in the strong sense. Animals may of course observe demonstrations, but their actions are not directly forced, teleoperated by other animals. Another important note he makes is that even if you just treat pre-training as an initialization of a prior, before you fine-tune with reinforcement learning, Sutton sees the approach as tainted with human bias and fundamentally off course. A bit like when AlphaZero, which has never seen human games of Go, beats AlphaGo, which initializes from them. In Sutton's worldview, all there is an interaction with the world via reinforcement learning, where the reward functions are partially environment-specific, but also intrinsically motivated, e.g. fun, curiosity, and related to the quality of the prediction in your world model. And the agent is always learning at test time by default. It's not trained once and then deployed thereafter. Overall, Sutton is a lot more interested in what we have common with the animal kingdom instead of what differentiates us. If we understood a squirrel, we'd be almost done. As for my take, first, I should say that I think Sutton was a great guest for the pod, and I like that the AI field maintains entropy of thought, and that not everyone is exploiting the next local iteration, LLMs. AI has gone through too many discrete transitions of the dominant approach to lose that, and I also think that his criticism of LLMs as not bitter lesson pilled is not inadequate. Frontier LLMs are now highly complex artifacts, with a lot of humanness involved at all the stages. The foundation, the pre-training data, is all human text. The fine-tuning data is human and curated. The reinforcement learning environment mixture is tuned by human engineers. We do not in fact have an actual, single, clean, actually bitter lesson pilled, turn the crank algorithm that you could unleash upon the world and see it learn automatically from experience alone. Does such an algorithm even exist? Finding it would of course be a huge AI breakthrough. 2 example proofs are commonly offered to argue that such a thing is possible. The first example is the success of AlphaZero learning to play Go completely from scratch with no human supervision whatsoever. But the game of Go is clearly such a simple, closed environment that it's difficult to see the analogous formulation in the messiness of reality. I love Go, but algorithmically and categorically, it is essentially a harder version of tic-tac-toe. The second example is that of animals, like squirrels. And here, personally, I'm also quite hesitant whether it's appropriate, because animals arise by a very different computational process and via different constraints than what we have practically available to us in the industry. Animal brains are nowhere near the blank slate they appear to be at birth. First, a lot of what is commonly attributed to learning is emo, a lot more maturation. And second, even that which clearly is learning and not maturation is a lot more fine-tuning, on top of something clearly powerful and pre-existing. Example. A baby zebra is born, and within a few dozen minutes it can run around the savannah and follow its mother. This is a highly complex sensory motor task, and there is no way in my mind that this is achieved from scratch. Tabula rasa. The brains of animals and the billions of parameters within have a powerful initialization encoded in the ATCGs of their DNA, trained via the outer loop optimization in the course of evolution. If the baby zebra spasmed its muscles around at random as a reinforcement learning policy would have you do at initialization, it wouldn't get very far at all. Similarly, our AIs now also have neural networks with billions of parameters. These parameters need their own rich, high information density supervision signal. We are not going to rerun evolution. But we do have mountains of internet documents. Yes, it is basically supervised learning that is irabsent in the animal kingdom. But it is a way to practically gather enough soft constraints over billions of parameters to try to get to a point where you're not starting from scratch. TLDR, pre-training is our crappy evolution. It is one candidate solution to the cold start problem, to be followed later by fine-tuning on tasks that look more correct, e.g. within the reinforcement learning framework, as state-of-the-art frontier LLM labs now do pervasively. I still think it is worth to be inspired by animals. I think there are multiple powerful ideas that LLM agents are algorithmically missing that can still be adapted from animal intelligence. And I still think the bitter lesson is correct, but I see it more as something platonic to pursue, not necessarily to reach, in our real world and practically speaking. And I say both of these with double-digit % uncertainty and cheer the work of those who disagree, especially those a lot more ambitious, bitter lesson-wise. So that brings us to where we are. Stated plainly, today's frontier LLM research is not about building animals. It is about summoning ghosts. You can think of ghosts as a fundamentally different kind of point in the space of possible intelligences. They are muddled by humanity, thoroughly engineered by it. They are these imperfect replicas, a kind of statistical distillation of humanity's documents with some sprinkle on top. They are not platonically bitter lesson-pilled, but they are perhaps practically bitter lesson-pilled, at least compared to a lot of what came before. It seems possibly to me that over time, we can further fine-tune our ghosts more and more in the direction of animals, that it's not so much a fundamental incompatibility, but a matter of initialization in the intelligence space. But it's also quite possible that they diverge even further and end up permanently different, un-animal-like, but still incredibly helpful and properly world-altering. It's possible that ghosts, animals, planes, birds. Anyway, in summary, overall and actionably, I think this pod is solid real talk. From Sutton to the frontier LLM researchers, who might be gear shifted a little too much in the exploit mode. Probably we are still not sufficiently bitter lesson-pilled, and there is a very good chance of more powerful ideas and paradigms other than exhaustive bench building and benchmaxing. And animals might be a good source of inspiration. Intrinsic motivation, fun, curiosity, empowerment, multi-agent self-play, culture. Use your imagination.
On October 02, Andrej replied,
Judging by mentions overnight, people seem to find the ghost analogy provocative. I swear I don't wake up just trying to come with new memes. But to elaborate briefly why I thought it was a fun comparison. 1, it captures the idea that LLMs are purely digital artifacts that don't interact with the physical world, unlike animals, which are very embodied. 2, ghosts are a kind of echo of the living, in this case a statistical distillation of humanity. 3, there is an air of mystery over both ghosts and LLMs, as in we don't fully understand what they are or how they work. 4, the process of training LLMs is a bit like summoning a ghost, i.e. a kind of elaborate computational ritual on a summoning platform of an exotic megastructure, GPU cluster. I've heard earlier references of LLM training as that of summoning a demon, and it never sounded right because it implies and presupposes evil. Ghosts are a lot more neural entity, just like LLMs, and may or may not be evil. For example, one of my favorite cartoons when I was a child was Casper the Friendly Ghost, clearly a friendly and wholesome entity. Same in Harry Potter, e.g. nearly headless Nick and such. 5. It is a nod to an earlier reference, Ghost in the Machine, in the context of Descartes' mind-body dualism, and of course later derived references, Ghost in the Shell, etc. As in the mind, ghost, that animates a body machine. Probably a few other things in the embedding space. Among the ways the analogy isn't great is that while ghosts may or may not be evil, they are almost always spooky, which feels too unfair. But anyway, I like that. While no analogy is perfect, they let you pull in structure laterally from one domain to another as a way of generating entropy and reaching unique thoughts.
On October 01, Andrej quoted someone, introducing Tinker, a flexible API for fine-tuning language models. Write training loops in Python on your laptop. We'll run them on distributed GPUs. Private beta starts today. We can't wait to see what researchers and developers build with cutting-edge open models. Andrej responded.
Tinker is cool. If you're a researcher developer, Tinker dramatically simplifies LLM post-training. You retain 90% of algorithmic creative control, usually related to data, loss function, the algorithm, while Tinker handles the hard parts that you usually want to touch much less often. Infra, forward-backward of the LLM itself. Distributed training, meaning you can do these at well below 10% of typical complexity involved. Compared to the more common and existing paradigm of upload your data, we'll post-train your LLM. This is EMO, a more clever place to slice up the complexity of post-training, both delegating the heavy lifting, but also keeping majority of the data algorithmic creative control. I think the community still has to discover how and when fine-tuning makes sense compared to the often strong baseline of prompting a giant model. The early indications I've seen is that fine-tuning isn't so much about stylizing an LLM. Instead, it's a lot more about narrowing the scope, and especially when you have a lot of training examples. An extreme example of scope narrowing being that of categorical classifiers, e.g. spam filters, content filters, etc. But it should be broader than that. Instead of building a giant few-shot prompts for a big LLM, it might work a lot better and faster to fine-tune a smaller LLM specifically for your narrow task. Increasingly, production applications of LLMs are larger pipelines where a bunch of LLMs collaborate in DAGs and flows. Some of these components might work well as prompts, but a lot of it will probably work a lot better as a fine-tune. Tinker makes the latter trivial and should allow for an easy experimentation of what works best at any stage.
Andrej replied.
Something I am experimenting with. I copy-pasted 1. The full podcast transcript, 2. The Bitter Lesson blog post 3, my full post above, to ChatGPT. The interesting part is you can fork the conversation context to ask any questions and take it in whatever direction with chat.
More from Andrej on X. On September 25, Andrej quoted someone. In 2016, Geoffrey Hinton said, "We should stop training radiologists now since AI would soon be better at their jobs." He was right. Models have outperformed radiologists on benchmarks for a decade. Yet radiology jobs are at record highs, with an average salary of $520K. Why? Andrej responded.
AI isn't replacing radiologists. Good article expectation. Rapid progress in image recognition. AI will delete radiology jobs, e.g. as famously predicted by Geoff Hinton now almost a decade ago. Reality, radiology is doing great and is growing. There are a lot of emo-naive predictions out there on the imminent impact of AI on the job market. E.g. a year ago, I was asked by someone who should know better if I think there will be any software engineers still today. Spoiler, I think we're going to make it. This is happening too broadly. The post goes into detail on why it's not that simple. Using the example of radiology, the benchmarks are nowhere near broad enough to reflect actual, real scenarios. The job is a lot more multifaceted than just image recognition, deployment realities, regulatory, insurance and liability, diffusion and institutional inertia. Jevons paradox. If radiologists are sped up via AI as a tool, a lot more demand shows up. I will say that radiology was not among the best examples to pick on in 2016. It's too multifaceted, too high risk, too regulated. When looking for jobs that will change a lot due to AI on shorter timescales, I'd look in other places. Jobs that look like repetition of one rote task, each task being relatively independent, closed, not requiring too much context, short in time, forgiving the cost of mistake is low, and of course automatable giving current and digital capability. Even then, I'd expect to see AI adopted as a tool at first, where jobs change and refactor, e.g. more monitoring or supervising than manual doing, etc. Maybe coming up, we'll find better and broader set of examples of how this is all playing out across the industry. About 6 months ago, I was also asked to vote if we will have less or more software engineers in 5 years. Exercise left for the reader. Full post. The works in progress newsletter is quite good.
On September 22, Andrej posted.
Anytime someone takes a picture video that I happen to be in the background of, I like to wave at the AGI that sees me 30 years from now.
On September 13, Andrej quoted someone. It just hit me that sub-1B parameter models that are way better than 75B GPT-3 are a dime a dozen today. Kinda cool. Andrej responded.
Reminded of this paragraph from GSMAK paper, 2021.
On September 09, Andrej posted.
Bit silly, but I still watch the Apple event live stream for new iPhones, every year since the first one in 2007. It doesn't make sense, but it's ok. Live stream today at 10 a.m. in 1.5 hours. This year, crossing my fingers again for an iPhone mini that I know won't come. So, yep.
On September 05, Andrej posted,
I think congrats again to OpenAI for cooking with GPT-5 Pro. This is the third time I've struggled on something complex gnarly for an hour on and off with CC, then 5 Pro goes off for 10 minutes and comes back with code that works out of the box. I had CC read the 5 Pro version and I wrote up 2 paragraphs admiring it. Very wholesome. If you're not giving it your hardest problems, you're probably missing out.
On August 28, Andrej posted,
Ticket, I wonder if the timeline over at Substack is better. Maybe there is less slop and more interesting long form or so on. Open Substack.
Andrej posted,
Transforming human knowledge, sensors and actuators from human first and human legible to LLM, first and LLM legible, is a beautiful space with so much potential and so much can be done. One example I'm obsessed with recently, for every textbook PDF FECAPUB, there is a perfect LLMification of it intended not for human, but for an LLM, though it is a non-trivial transformation that would need human in the loop involvement. All of the exposition is extracted into a markdown document, including all latex, styling bold italic, tables, lists, etc. All of the figures are extracted as images. All worked problems get extracted into SFT examples. Any reference made to previous figures, tables, etc. are parsed and included. All practice problems are extracted into environment examples for RL. The correct answers are located in the answer key and attached. Any additional information is added as answer key for a potential LLM judge, synthetic data expansion. For every specific problem, you can create an infinite problem generator, which emits problems of that type. For example, if a problem is, what is the angle between the hour and minute hands at 9 a.m., you can imagine generalizing that to any arbitrary time and calculating answers using Python code, and possibly generating synthetic variations of the prompt text. All of the data above could be nicely indexed and embedded into a RAG database for later reference, or maybe MCP servers that make it available. Then just as a human student could take a high school physics course, an LLM could take it in the exact same way. This would be a significantly richer source of legible, workable information for an LLM than just something like PDF to text, current prevailing practice, which simply asks the LLM to predict the textbook content top to bottom token by token, WM, lame. As just a quick and crappy example of synthetic variations of the above example, GPT-5 gave me this problem generator, CImage, which can now generalize that problem template to many variations, when the time is 11,007 a.m. What is the degree measure of the angle between the hands? Answer, 68. Determine the angle in degrees between the clock's hands at 4004 a.m. Answer, 43. What angle did the clock hands form when the time reads 11,047 a.m.? Answer, 71. At 7,002 a.m., what angle separates the hour hand and the minute hand? Answer, 61. At 4:14 a.m., calculate the angle made between the two hands. Answer, 43. What angle is formed by the hands of a clock at 4:45 p.m.? Answer, 27. What is the angle between the hour and minute hands at 8,037 p.m.? Answer, 36. Infinite practice problems can be created.
On August 27, Andrej quoted someone, introducing the Environments Hub RL. Environments are the key bottleneck to the next wave of AI progress, but big labs are locking them down. We built a community platform for crowdsourcing open environments so anyone can contribute to open source AGI. Andrej responded,
In era of pre-training, what mattered was internet text. You'd primarily want a large, diverse, high-quality collection of internet documents to learn from. In era of supervised fine-tuning, it was conversations. Contract work is a hide to create answers for questions, a bit like what you'd see on Stack Overflow Quora, or etc., but geared towards LLM use cases. Neither of the two above are going away, emo, but in this era of reinforcement learning, it is now environments. Unlike the above, they give the LLM an opportunity to actually interact, take actions, see outcomes, etc. This means you can hope to do a lot better than statistical expert imitation, and they can be used both for model training and evaluation. But just like before, the core problem now is needing a large, diverse, high-quality set of environments as exercises for the LLM to practice against. In some ways, I'm reminded of OpenAI's very first project, Jim, which was exactly a framework hoping to build a large collection of environments in the same schema, but this was way before LLMs. So the environments were simple academic control tasks of the time, like Carpol, Atari, etc. The ePrimeIntellect Environments Hub and the Verifiers repo on GitHub builds the modernized version specifically targeting LLMs, and it's a great effort idea. I pitched that someone build something like it earlier this year. Environments have the property that once the skeleton of the framework is in place, in principle the community industry can parallelize across many different domains, which is exciting. Final thought. Personally and long-term, I am bullish on environments and agentic interactions, but I am bearish on reinforcement learning specifically. I think that reward functions are super SUs, and I think humans don't use RL to learn, maybe they do for some motor tasks, etc., but not intellectual problem-solving tasks. Humans use different learning paradigms that are significantly more powerful and sample efficient, and that haven't been properly invented and scaled yet, though early sketches and ideas exist. As just one example, the idea of system prompt learning, moving the update to tokens. Context, not weights, and optionally distilling to weights is a separate process, a bit like sleep does.
And replied,
How amazing it would be if we could extract and reframe all the practice problems from all the textbooks ever written into environments.
On August 24, Andrej posted,
Continuing the journey of optimal LLM-assisted coding experience. In particular, I find that instead of narrowing in on a perfect one thing, my usage is increasingly diversifying across a few workflows that I stitch up the pros cons of. Personally, the bread and butter, 75%, of my LLM assistance continues to be just cursor tab complete. This is because I find that writing concrete chunks of code comments myself, and in the right part of the code is a high bandwidth way of communicating task specification to the LLM, i.e., it's primarily about task specification bits. It takes too many bits and too much latency to communicate what I want in text, and it's faster to just demonstrate it in the code and in the right place. Sometimes the tab complete model is annoying, so I toggle it on off a lot. Next layer up is highlighting a concrete chunk of code and asking for some kind of a modification. Next layer up is Claude Coder Codex running on the side of Cursor, which I go to for larger chunks of functionality that are also fairly easy to specify in a prompt. These are super helpful, but still mixed overall and slightly frustrating at times. I don't run in YOLO mode because they can go off track and do dumb things you didn't want to need in IESC fairly often. I also haven't learned to be productive using more than one instance. In parallel, one already feels hard enough. I haven't figured out a good way to keep clues. MD good or up to date? I often have to do a pass of cleanups for coding style or matters of code taste. E.g., they are too defensive and often overuse try-catch statements. They often overcomplicate abstractions, they overblow code, dgg.g. And nested if the else constructs, when a list comprehension or a one-liner if then else would work, or they duplicate code chunks instead of creating a nice helper function, things like that. They basically don't have a sense of taste. They're indispensable in cases where I inch into a more vibe coding territory where I'm less familiar. E.g. writing some Rust recently, or SQL commands, or anything else I've done less of before. I also tried CC to teach me things alongside the code it was writing, but that didn't work at all. It really wants to just write code a lot more than it wants to explain anything along the way. I tried to get CC to do hyperparameter tuning, which was highly amusing. They're also super helpful in all kinds of lower stakes one-off custom visualization or utilities or debugging code that I would never write otherwise because it would have taken way too long. E.g. CC can hammer up 1,000 lines of one-off extensive visualization code just to identify a specific bug, which gets all deleted right after we find it. It's the code post-scarcity era. You can just create and then delete thousands of lines of super custom, super ephemeral code now. It's okay. It's not this precious, costly thing anymore. Final layer of defense is GPT-5 Pro, which I go to for the hardest things. E.g., it has happened to me a few times now that I cursor CC are all stuck on a bug for 10 minutes, but when I copy paste the whole thing to 5 Pro, it goes off for 10 minutes, but then actually finds a really subtle bug. It is very strong. It can dig up all kinds of esoteric docs and papers and such. I've also used it for other meatier tasks, e.g. suggestions on how to clean up abstractions, mixed results, sometimes good ideas, but not all, or an entire literature review around how people do this or that, and it comes back with good relevant resources, p-pointers. Anyway, coding feels completely blown open with possibility across a number of kinds of coding and then a number of tools with their pros cons. It's hard to avoid the feeling of anxiety around not being at the frontier of what is collectively possible. Hence, random Sunday shower of thoughts and a good amount of curiosity about what others are finding.
More from Andrej. On August 18, Andrej posted,
I get 8-10 spam calls per day, various automated voicemails, loan pre-approval, etc., and 8-5 spam messages per day, usually phishing. I have AT&T Active Armor. All of the above still slips through. All of the above is always from new unique numbers, so blocking doesn't work. I am on all do not call lists. I have iOS silence. Unknown callers on. But even if it catches and silences them, I still get the notifications. Not sure if other people are seeing something similar or figured out anything that works.
That's been This Week with Andrej Karpathy. If you enjoyed this, subscribe and visit xNarrator.com for your own personal feed, narrated daily.